we assigned electrons are moving in a conductor random with ordered motion. Random with ordered motion. So that we concluded. Right? So therefore, with ordered motion in an move with constant speed? No, we cannot. So they are not moving with a constant average speed. They are moving average speed. Here we can call it as drift speed or drift velocity. It is the speed or average speed called as drift velocity. So how to calculate that drift velocity speed? So let's accelerated continuous collisions. So here constant average speed. So here expecting right that electrons are crossing the cross-sectional area in a given time. We are unable to visualize that, but we are predicted. Here we need to know. So that is assumed as here A. So the cross-sectional area in a particular take something D here. Before that, I am showing you here the region between them. Right? Three-dimensionally I considered. Right? Three-dimensionally I considered. So one directed to move in a specified direction. So here, what distance that can travel in a given time is equal to 1 second. Right? So that we can predict here. So that is 1 second is assumed as unknown distance is taken as small d. We don't know the distance, what distance to move with a constant speed called as average velocity or average speed given as here drift velocity or drift speed. So drift velocity or drift speed is assumed as here simply Vd. That is assumed as here Vd. Each electron moving with a constant average speed. Right? So that I assumed here as Vd. So according to that, here charge is crossing the cross-sectional area in a given time. So what charge to what I can write Q by T. Capital Q is what? E. Cost equal to R speed is by time depending vector quantity by time. That is a given time equal to D by 1. That will give you V drift speed or drift velocity. V equal to what? I got. Then here I am rated area, right? The region length. So that is simply cylinder. Cylinder volume. So area of the base is taken A. So what will get A into D? But I got to D is equals to Vd. So substitute that, then the volume will be taken as here A into Vd. A into Vd. So how many number of charges are present in this volume? So that we will find out. So Q equal to what? N into Q. Number of charges into amount of charge. So Q is net charge. Q is equals to number of charges into charge of each particle or unit charge multiplied by unit charge. So that is called as here net charge. But it is in a given unit volume. So we don't know the volume. So that volume is taken as unknown value something. So within the volume, these number of charges are present. What is the volume here? Vd into A. So that we can substitute here. Then the net charge is considered over here. Q is equals to N into Q into A into Vd is given as net current I is taken as N into Q into A into Vd by T. But T is considered here 1 second. So that's why I am writing here I equal to N into Q into time T equal to 1 second. So I got I equal to transposing. I'll write Vd equal to. So what I can write Vd by N into Q into Vd. Right? So that we can write here. So Vd is equals to I by. So this is the formula components here. I is N is number of charges. Q is charge area of the conductor. Cross-sectional area. Right? Cross-sectional area. What the formula for finding current? I equal to, is it clear? So now, right, we are trying to find out that drift velocity. So Vd equal to, here N is number of charges, Q is the electron charge, A is the area, cross-sectional area of the conductor. So if I know the current and the remaining value, then I am able to calculate Vd. So I am assuming that simply here electric current because of charge carriers, they are decided as here electrons. So now I am predicting that amount of current through the conductor is charge is 1.602 into 10 to the power minus 19 coulombs. The charge of or magnitude of the electron charge is 1.602 into 10 to the power minus 19 coulombs. Then we assumed already current is 1 ampere. Then we need to know N value and A value. Already I know the Q value. charge of electron, right? So what is N? N is number of electrons present in the unit volume. So that is given here for a copper wire having the cross-sectional area 10 to the power of minus 6 square meters, 10 to the power of minus 6 square meter, right? That wire consists in its unit volume is equal to 8.5 into 10 to the power of 28 per cubic meter. 1 cubic meter, what copper wire consists these number of charges, 8.5 into 10 to the power of 28. So these are all practical values I am given. So let us substitute these values in the formula VD equal to I is 1 by N. N is 8.5 into 10 to the power of 28 into Q, 1.602 into 10 to the power of minus 19, and area is 10 power minus 6 square meters. So no need to substitute the units here. So I substituted all the values. Then first take the products of this of exponents there. So 28 minus 19 will give you plus 9. Plus 9 into 10 power plus 3 we will get. So 2 into 10 power 3. So this is simplified. That will give you 13.7 something into 13.617 something you will get. So approximately 1 decimal point only considered 13. So 10 power plus 3 taking to the numerator. So will become negative. Then 1 by 13.6 by cancellation will get 0.07. So 0.07 into 10 power minus 3, right? So this is in meters. So here 10 power minus 3 is standing for milli. So I am writing VD equal to 0.07 millimeter per second. 0.07 millimeter per second. So I got drift speed or drift velocity value I 0.07 millimeter per second. 0.07 millimeter per second. So this is the average speed of the electron within the conductor. So is it a very faster or very slower? How the electron is moving? Its speed is large or very smaller? Actually, it is negligible, slower than the, right? So from this, we will get one doubt here, right? So it takes nearly 100 seconds time. It takes nearly 100 seconds time to cover 7 millimeter. It is less than 1 centimeter in 100 seconds of time. That is more than 1 minute, 1.5 minutes. Right? So here to move 7 millimeters, it is taking 100 seconds. Then if you switch on, immediately the bulb glows irrespective to the length of the wire. How it is possible? Right? Irrespective to the any length of the conductor, that bulb glows immediately. What could be the reason for that? That reason is simple one, uniform electric field. So immediately once you switch on, that electric field uniformly set up throughout the conductor within very smaller time, right? So comparing with this, it is very smaller that time. So set up the uniform electric field, the electron which is very close to the bulb, that will reach the bulb. So immediately the bulb glows, right? So maybe you got the idea how the bulb glows immediately when the electron is smaller rate, that is 0.07 millimeter per second.